Welcome to Chapter 2. We're going to be covering algorithms and design in a series of 2 lectures. The first thing that we're going to be talking about before we start algorithms and design is the software that you're going to need on your machine or that we will be using during the class this semester. So if you open up your Canvas course, there is a link that will tell you about the 2 programs, the software programs that we're going to be using in our class. The first one is called JGrasp, and the second one is called NetBeans. And in order to use either one of these software programs, also called Integrated Development Environments, or IDEs, you're going to need some software on your machine that will allow the program to go from your plain language, Java, into a machine language that your computer can understand, and that is called a JDK, or a Java Development Kit. And in order for either one of these software programs to work, NetBeans or JGrasp, you're going to need the JDK on your machine. And so if you'll notice in the instructions, it says that you can get NetBeans bundled with the JDK. So I would strongly encourage you to click on this first link, which will take you to Oracle, which will allow you to download and install NetBeans, which is bundled with the JDK. Then after you have completed that task and you have the JDK and NetBeans installed on your machines, then the second thing that you would want to do is install JGrasp. And you can either go to the JGrasp website itself, or you can click on this link and it'll allow you to download that software from there. Once you have the software on your machine, the next thing that we're going to be talking about is pseudocode and flowcharting. So let's talk about algorithm and design first, as a preamble to our pseudocode and flowcharting. It would be really nice if we could just jump into programming and start hacking out some code, sit down at a keyboard and just start mashing a bunch of keys to come up with some code. But this is an introduction to programming class, not an introduction to Java. So I'm going to introduce you to the concepts of programming using the language called Java. And one of the most critical, important parts of being a good programmer is having some problem-solving skills. Now, we are not naturally born with problem-solving skills. I can tell that because I see tiny little babies sitting together on a playground, and one will grab a block and the other one will say, mine, mine, and the first one will smack him across the head with it, and then everybody's crying. That's because as infants, we do not have problem-solving skills. It's something that we learn and something that we can develop and something that we can get better at. So, in order to be an effective programmer, you have to have some problem-solving skills. And I'll tell you, these problem-solving skills are different for the environment of programming than problem-solving skills that you may have had in the past, like how to get to class on time, or how to get a good grade in your class, or how to even wake up in the morning and come to class, because there's a thought process that's involved as a programmer. If you have already had some programming experience, you know what I'm talking about. If you don't, it is something that we can learn. So the first step that I'm going to have you do is I'm going to give you a topic, and I want you to list in exactly 3 steps how to complete this topic from start to finish in exactly 3 steps. And so I tell you that we could solve world hunger in exactly 3 steps. So make them very global, very grand. And the task that I'm going to give you is, we have a mama bear who needs to gather some honey. So the beginning position of this problem that we have to solve is a mama bear at the end of a long hibernation, and she is just waking up in her cave. That is the starting point of our problem. The end result is the mama bear with honey in hand, no longer hungry. So we start with a hungry mama bear in her cave. The one caveat I would say is that she cannot eat her young. She must leave the cave. So the starting point, we have a hungry mama bear. The end point, she's got honey in hand and she is no longer hungry. So in exactly 3 steps, I want you to solve this problem. I'm going to pause this here, or I'm going to have you pause this here in order to be able to write down exactly 3 steps. Once you have exactly 3 steps, the next thing that I'm going to have you do is I'm going to have you take each one of those 3 steps and break it into 3 distinct steps. You're going to have a total of 9 steps now. So pause this recording to take each of those 3 steps that you just created and break it into 3 steps for a total of 9. Now I'm going to have you take each of those 9 steps and break it into 3 steps. So you'll have a total of 27 steps. I'll give you a chance to, or you can pause the recording here in order to be able to do that. So you should have 27 steps. Gallery is I want you to take one step out of all 27 that you have written. I want you to find the most complex, just pick out one and break it into 3 additional steps. You will now find yourself with a total of 30 steps. You can pause the recording here to be able to do that. If I were to say to you just a few minutes ago, I want you to solve the problem of a hungry mama bear in exactly 30 steps, would it have been difficult for you to do? I'm assuming that you're nodding your head. Yeah, in exactly 30 steps, it would have been very difficult for me to do. But I'll tell you, we could take any problem and we can create some high-level solutions to it and then come back and add detail and a little bit more detail and add even more detail and more detail until we have something that becomes more manageable. And so this is one problem-solving method that you can use to take something that might seem huge, like global hunger, world hunger, or something very, very small, like how am I supposed to get myself up on time so that I can come to class on time? And I can apply this as one problem-solving step. And we're going to be doing a lot of this as we move through the semester. All right, so it's just a series of steps. Just list out in plain language a series of steps that I would need to take to solve any particular problem. So let's say, for instance, I wanted to take a quiz in Canvas. The first step would be to sit down in a chair, sign into Canvas. If I have the wrong password, try it again. Once I get in, I'm going to click on a link to a quiz. I'm going to read the question. If you don't know the answer to the question, select it. If you do know the answer to the question, select the answer. If you don't know the answer to the question, frantically search the textbook for the answer. If you still don't know the answer, try to remember the rule for the most common answer to a true and false or multiple choice question. And you repeat this until you have no more questions. And then finally, you swear to read the chapter next time. So this is just a series of plain language sort of steps that I would take in order to solve a problem of taking a quiz. All right, so your turn again. What I want you to do is I want you to write a series of steps for your typical morning routine. You're going to start with yourself sound asleep in your fuzzy slippers and your jammies, and you're going to end with your hand on the door to leave to your first destination of the day. I'm not going to tell you how many steps that I want you to use to solve this problem, but I want it to be more than 3 and less than 20. In your own words, write down the steps to your typical day. You can pause the recording while you do that. One of the things that I might encourage you to do, and you may have noticed a problem with the mama bear gathering honey, is that if you start out with steps that are not equal in nature, that it can become very difficult to drill down or add detail to the steps. So if your first step was mama bear wakes up and yawns, the second step was mama bear goes out and finds honey, and the third step was mama bear eats the honey, you're going to have a significant amount of difficulty adding detail to mama wakes up and yawns. So I would strongly encourage you to try, to the best of your ability, to give each step an equal amount of effort and time required, because then it makes it easier to break down. All right, so you should have your steps to your typical morning routine. If you need to go back and modify the steps so that each step requires a specific or a relatively equal amount of time and effort, now would be the time to do that. All right, so you're getting better at this. Now we find ourselves with your hand on the door ready to go to your first destination. Again, once again, I want you to create a series of steps from start to finish to solve the problem. And the problem is your hand is on the door, and now you need to be at your first destination, wherever that is. If your first destination generally is you go to work, you go to school, you go to IHOP for breakfast, or you go to the gym to work out that breakfast that you just ate, I want you to write down a series of steps to get to your first destination of the day. where your starting point is you are getting in your vehicle, or maybe I should say you are leaving your home, and the end of the problem is that your hand is on the door at your first destination. Once again, I'm not going to tell you how many steps to use, but somewhere between 3 steps and 20 would be excellent. All right, so you've had a couple of times to practice I have to think about the idea of solving a problem using a series of steps. And this is pretty much what pseudocode is. Pseudocode is plain language English that allows us to write down a series of steps to solve a problem. So the first thing that I would do when I was writing pseudocode, somebody comes to you and they say, I want you to write a software program for me to do something. And the first step that you can do is begin by outlining the steps. If I have a software program, there's a very good chance that I'm going to need input from a user. For instance, we are writing a program to convert Fahrenheit temperatures. Somebody's come to you as a development team, is willing to pay you the big bucks to write a software program that will allow them to convert from Fahrenheit to Celsius or Celsius to Fahrenheit. How do I go about creating a plan, coming up with some kind of plan to be able to do this? So I know that I'm probably going to have to get input from the user. The second thing I'm going to probably have to do is do some kind of conversions from Fahrenheit to Celsius or Celsius to Fahrenheit. And the last thing that I'm going to probably have to do is display those results to the user. Because what good is a whole bunch of calculations if the end user never gets to see what they are? So I begin by outlining the series of steps that I need to take. The second thing that I want to do is come back now and add some detail to each one of those. So I have no idea what the formulas are for the conversion, so I'm going to go out and do a Google search, and I'm going to find out what those two conversion formulas are, and I'm going to have them at the ready. The next thing that I need to do is decide if I'm going to have to get information from the user, how should I phrase that? What kind of information do I need to get? Well, the first thing I'm pretty sure I'm going to need to get is, do you want to convert from Celsius to Fahrenheit or in the reverse? The second thing that I'm probably going to have to ask for the user is, what temperature do you want to convert? And then the last thing that I need to do to add detail is, if I'm going to be displaying something to my user, what do I want it to look like? It's never a good idea to just pop a number on the screen. 14. I mean, what does that 14 mean? So it's always a good idea to create a positive user interface that helps remind them of the information that they gave me and or give them a context for the information that I'm trying to give them. So 32 degrees Fahrenheit is 0 degrees Celsius. I'm going to assume that they wanted to convert 32 degrees from Fahrenheit to Celsius. I'm going to remind them the information they gave me, 32 degrees, and then I'm going to tell them within context what my calculations were. So now I have some detail to this program that I want to write, and it would look something like this. Input from the user, convert Celsius to Fahrenheit, and the temperature to convert, then the two calculations that I'm going to have to do, and finally, the results of my conversion. And this is an example in plain language English of pseudocode. It's called pseudocode because it is pseudo or fake code compared to source code, which is real code. And all of your problems should start, all of your software programs should start with some kind of pseudocode. You should have some kind of plan. Maybe not a full-blown, detailed, step-by-step, exactly what I'm going to do, but you need to have a plan before you write any software program, even the most simple software program. Unless you want to hack out something that is difficult to understand or very convoluted, if you want to have an effective, efficient program, you need to start with some kind of a plan. And the example I always use is building your dream house. You go down to Home Depot and you fill up your truck with 2x4s and nails and your hammer, and then you just go out and find some spare piece of ground and throw the wood on the ground and just start hammering out your dream house. Is that the way I go about building even a dog house or even a bird house? Or do I have some kind of plan in mind before I ever start? That's what I consider pseudocode to be, some kind of a plan. All right, so now it's your turn again. I want you to break out that same piece of paper, that document, and I want you to write the pseudocode to calculate a paycheck. Somebody has come to your development team and they're going to pay you the big bucks to create a software program that will allow them to calculate a paycheck for one employee. Now, for the purposes of our program here, we just want to do it for one. Just one employee is good. Keep it in mind that paychecks involve some kind of a base pay, some kind of hours worked, and there has got to be some kind of a tax rate. So pause this video while you work out some pseudocode that allows a software program to calculate some kind of a paycheck. All right, so one of the best ways that we can know if there's holes in my pseudocode would be to test it on a partner. So at this point in time, I have you divided up in your class into partners, pairs of 2, or at the most pairs or groups of 3. And I'm going to have you turn to your partner now, and step by step, I'm going to have you ask your partner questions, or break out your calculator and start calculating things, or giving some kind of an end result to your partner. Now, if your pseudocode doesn't have you asking your partner anything, I would ask you this question. Where do you expect to get the information from that is required of calculating a paycheck? Where are you going to get that information from? The base pay, the number of hours worked. Well, hopefully you've gotten it from the user of some kind. So moving step by step through your pseudocode, ask your partner the questions or provide the answers in your pseudocode. You might find that you have left some things out. You might find that there are some things in there that are not necessary. Once you've tested it on your partner, then you can modify your pseudocode as necessary. All right, here's an example of some pseudocode that would allow us to calculate a restaurant bill with a tax and tip. If somebody came to me, a restaurant came to me and said they needed me to write some software that would allow them to calculate a total for a single order, this is what that pseudocode might look like. First, I need to find out the bill amount. I need to determine the tax rate, and I need to determine the tip rate. And I ask you, would I probably ask the user for the tax rate or the tip rate, or would that be something that I set myself? Once I have determined the tax and the tip rate, the next thing I need to do is calculate the tax and the tip. Then I need to add them together to the bill amount, and I have to display that bill total. So this is an example of some pseudocode that I would create in order to calculate a restaurant bill. This is going to be the end of this particular lecture. The second lecture is going to continue with this theme as we learn more and more about algorithms and design.